Hi guys, Brenton from Phaser FPV here with part 2 of our SourceOne build. Betaflight 4.1 setup, installation and drivers. Let's begin by opening our internet browser and searching for the latest Betaflight configurator releases. We want the official Betaflight GitHub, and on this page you'll find the latest pre-release candidates, and just underneath, the latest release candidate that's been verified. At the bottom, under the subheading Assets, you'll find a list of installers for your operating system. Let's open our Betaflight installer, select Next, agree to the terms and conditions, and select an install location. While that finishes up, let's jump back over to our browser and download our USB drivers to connect our flight controller to the computer. Search for Impulse RC Driver Fixer and select to the link to their downloads page. First up on the list, we have the Impulse RC Driver Fixer. Select File Save As and move that to a handy location. When Betaflight finishes installing, select Run Betaflight Configurator and hit Finish. Upon opening Betaflight, you'll notice we can't select a device to connect to just yet. We need to install our drivers. You can download them all manually here from the home page if need be, otherwise run the Impulse RC Driver Fixer that we downloaded earlier. When the installation is complete, if you see a green success bar, pause the video and continue to flashing your flight controller. If not, continue watching and I'll show you how to install the drivers manually. To install our CP210 driver, extract the folder and select the install application respective to your machine, 64 or 86. Hit Next and then Finish. Same for the VCP driver, select your operating system's corresponding file, hit the Setup, and hit Install. Hit Next, select a location for the driver, and hit Next again. Finally, Finish. You can update or simply finish the setup. One last thing is installing our Win USB driver using Zadig. Open Zadig and select Options, List All Devices. Select the STM32 bootloader, Win USB 6.1, and hit Install Driver. I already have this installed, but I'll reinstall it anyway. Once you've finished doing this, open up Betaflight and see if you can connect your flight controller, and we'll move on to flashing. Your device should now be in DFU mode. We can continue to the Firmware Flasher tab on the left hand side and begin flashing our flight controller. Once this page is loaded, select your flight controller from the drop down menu above. We will be installing version 1.6 and using a full chip arrays. To load our firmware, I'm going to select the Load Firmware Online button down the bottom right hand corner, and you'll see details about the latest release appear in this section above. Continue to flash firmware. This will erase everything that's currently on the flight controller and begin uploading the new firmware. When you see programming successful, that means the flashing's complete, and we just need to give Betaflight a restart so that we can see our flight controller and connect out of DFU mode. Once you've connected, apply any custom defaults and close Betaflight for now. Before we move on to anything further in Betaflight, I want to install BLHeli 32 configurator for our ESC. Look this up in your browser and find the BLHeli GitHub. You can download it from their Google Drive link, and we want the BLHeli 32 suite. Hit download. Extract your BLHeli 32 folder. Once extracted, open the folder and run the BLHeli 32 application. Select your COM port, hit connect. Now we want to read our setup, but we get an error. We need to plug in our LiPo. Before you do, always make sure you use a smoke stopper. And once it's powered on, we can hit read setup again. Should now see all 4 of your ESCs show up, and we can update those to the latest firmware. This ESC is already running 32.7, but if yours needs to be upgraded, hit the flash BLHeli button down the bottom and wait for this window to appear. We can now select the revision that we'd like to upgrade to, hit continue and yes, and wait for it to finish flashing. Once our ESCs are finished flashing, hit OK and disconnect. You'll get a message saying that we need to restart our ESC by disconnecting and reconnecting the power before use. Hit OK, wait for the flight controller to reboot, and disconnect your LiPo and flight controller before we move back onto Betaflight. Open Betaflight and hit connect. We want to work in our configuration tab and have a look at the ESC motor features and system configuration. Under ESC motor features, we want to change our protocol to DShot 300, and in our system configuration, the gyro and PID loop update to 4K and 4K. Hit save and reboot. Go ahead and reconnect, navigating to the CLI tab at the bottom left. Here, we're going to type in tasks and hit enter so we can check that our gyro and PID loop are running correctly. We want that rate value to be as close to 4K as possible, and a max loaded 22% gets thumbs up from me. Select the motors tab on the left hand side, and you should see all 4 of your motors showing up with a 100% error rate. This is because we haven't supplied them with any power yet. After plugging in a LiPo, you should see this error rate drop to 0. We can now test each of our motors and make sure that they're going in the right direction. Make sure that you remove all of your propellers before plugging in a LiPo and spinning up your motors. Select I understand the risks and slowly raise each of the sliders to double check that your motors are all spinning the correct direction. You can raise the master slider to spin all 4 motors at the same time. Uncheck that I understand the risks and disconnect. If you had any motors that were spinning the wrong direction, open up BLHeli Suite 32 and we'll correct this problem now. For those that didn't, this will be useful just so you know. With your LiPo still connected, hit the connect button and read our setup. You'll get a confirmation that all of your ESCs have booted correctly, and we'll be able to select the settings for each of them individually down the bottom. I'm selecting motor 1, as that was one of my motors that was spinning the wrong direction. Change the motor direction to reversed, and hit right setup. When this is complete, hit OK. I'm going to select my second motor that was spinning incorrectly and change its direction, write the setup, hit OK, and hit disconnect. BLHeli will reboot our flight controller, And we can jump back over to Betaflight and check our motors are all spinning correctly again in the Motors tab. Check each of your motors individually, make sure that they're all spinning in the right direction. When you're happy with that, turn off the motors and let's move on. Getting started with our PID and RPM filter settings, let's connect to Betaflight and have a look at our configuration tab. First, we need to enter our number of motor poles. You might need to count the number of magnets that are on your motor bell and put that here. We also want to turn on bidirectional D-shot. Hit save and reboot, and let's navigate over to the PID tuning tab. Here we can leave our PID profile settings all on default, and we just want to look at our filter settings for now. Coming down to our gyro RPM filter, we want to change our gyro RPM filter harmonics down to 1. Under our dynamic notch filter, we want to change the filter range to low, and our dynamic notch width percentage to 0. Dynamic notch Q to 200, and dynamic notch min hertz to 90. Hit save, and we can move on to our configuration tab for the next section. On our configuration tab, if we scroll down to the receiver subheading, we want to change our receiver mode to serial base receiver S-Bus and our serial receiver provider to S-Bus as well. We also want to turn on our telemetry tab just here so we can receive RSSI later on. Now let's navigate our way to the ports tab so that we can select the right UART for our receiver. To make sure that we're using the right UART, refer to your flight controller's user manual and check the pin out. On this board, we've used UART 4 for our receiver and UART 3 for our VTX. Returning to Betaflight, let's make sure that we've got UART 4 selected for our receiver, and on UART 3 we can enable VTX control via the IRC tramp protocol. This stack has ESC telemetry on UART 1, so I'll turn that on as well. Hit save and reboot. Let's bind our transmitter to our receiver. You can do this by creating a new model, clicking your wheel and selecting Create New Model, then using the Page button to navigate to the Setup page. Under Model Name, call your model whatever you like. Long presses will give you capital letters. Using your scroll wheel or buttons, navigate down to the internal RF mode. Make sure that we're on mode 16, channel range 1 to 16. Have your receiver handy and a LiPo ready to plug into your quad. With the bind button highlighted on your transmitter, select enter 1 to 8 telemetry on and select enter again. It'll begin to flash. While this is flashing, hold the bind button on your receiver and plug in your LiPo. This can be tricky, so I'll show you another way when this is done. You should see a green and blue light flash, and this will confirm that you've bound your radio. If you see a red light, then you have not bound and you need to try again. Before I show you another way to try this, scroll down to Failsafe and set this to no pulses. An easier way to do this binding process, if you find it difficult to hold the RXSR because it's such a tiny receiver, is to use a pencil tip or some tweezers to hold this while you plug in the LiPo. You should see the blue and green light turn on like so, and we're finished. Back in Betaflight, let's navigate to the receiver tab. With your transmitter turned on, you should be able to see these values changing when you move the sticks. Make sure that they all correspond to the correct stick and adjust them in the channel map if needed. Next we'll be looking at modes, but first we need to set up the switches on our transmitter. We're going to be using aux1 and aux2 to set up ARM and pre-ARM switches. On your transmitter, navigate to the model page 6 or mixer tab and select the next blank channel. Under source, press enter and flick a switch. It'll then put that switch as the source for that channel. This channel is going to be called pre-ARM, and I'm going to make one more for my arming channel. So press enter, select the switch that I want to use, and then give it a name. Once we've finished setting up this switch, we can return to Betaflight. In the receiver tab, you should be able to use your switches, move them backwards and forwards, and see the value changing. We can now go to Modes tab and set up our aux switches. I like to use a single value of 1800 or higher for my arming switch, so I'm going to adjust the slider to accommodate for that. Under the drop down, select the aux channel that you'd like to use for arming, and you'll see a little dial show up that will click backwards and forwards when you move your switch. If you want to switch aux1 and aux2, it's as easy as using the drop down. Hit save, go back to our receiver tab, and just make sure that you're getting all of those values recognized. You'll notice now that if you try to switch your aux channel into ARM, a red disabled flag will show up. This is preventative to make sure that you don't accidentally cut yourself, but nonetheless you should still always take your props off. Scrolling down, we can find our pre-ARM mode, and I've assigned this to aux2 already. Hit save. We can now go and set up our video transmitter. Before we can access Betaflight's VTX settings, we need to download a VTX table appropriate for our transmitter. For this example, I'll be using the IRC Tramp VTX table, but if you use a TBS product that has smart audio, select the corresponding file here. Right click and save link as. You want to save this document somewhere easily accessible, and it's a JSON file. Once you've saved it, open Betaflight, hit connect, and navigate to our transmitter tab. From here, we're going to load our VTX table from a file, and you can make any necessary adjustments after that. Finally, hit save, and we can move on. Open Betaflight up to the OSD tab, and have a look at our headings on the right hand side. Under video format, you have the option between PAL and NTSC, any warnings that you might want to show, and some post-flight statistics that will show up at the end of each flight. On the left, we can select different OSD elements to show. I'm going to use battery current draw, battery current milliamp hour draw, battery voltage, my RSSI value, VTX channel, and any warnings. I also like to stick on my disarmed flag just to make sure before I go running out and grabbing my quad. There's also a font manager for the OSD. You can choose different fonts, as well as also uploading custom boot images and your own fonts. And that brings us to the close. So once we hit save, you're all done. Happy flying, guys.